that last time we are dealing with the graph of the parabola, hyperbola I should say. Now, notice that the next thing that we are going to look into is another technique of plotting hyperbola. Okay? And what is the technique of plotting of the hyperbola? Notice that we have to go over first with our hyperbola. Our hyperbola in here is actually the horizontal hyperbola. Okay? Assuming that this is our hyperbola, again, we have in here the transverse axis along your x-axis. And of course, we have the y-axis. Now, we have in here the different points. Normally, in a problem, under the hyperbola, the given is always A, B, and C. Or even the equation. Okay? So those are the normal given. Or just an equation, standard form of the equation of the hyperbola, that is the given. Now, looking into that one, standard form of the equation of the hyperbola, it is only the A and B is the given. There is no such C, or there is no even focus. Okay? So, ayan, assuming that we have in here the drawing, you notice that when we go back, we have to at least go over with these distances. Okay? So what is that distance again? That is the distance, or that is the measure of the vertex from the center. Now notice that the vertex to the center is actually defined or determined by the value of A. Okay? By the value of A. Okay? So what is our vertices? We have in here the vertices that is the same as negative A, 0. How about in here? Positive A, 0. So that is the vertex. Now, what about the measure? Okay? Measure from the center going to the expected focus. Meaning to say, we have in here the focus 1. Okay? Focus 1. What must be that measure? That is the same as C. So meaning to say, if we are going to have this measure going to the expected focus, the measure of that one is actually C. Okay? So it will follow at the other side. So meaning to say, if it will follow at the other side, the expected focus is the same as focus 1, C, and 0. Do you follow? C and 0. Isulat mo, you write it down. Okay? Now what about at the other side? What is our focus 2? Our focus 2 in here is negative C and 0. So these are the coordinates. Okay? These are the coordinates of the common points or the points, the different points along the transverse axis. Okay? Along the transverse axis. So that is our focus 2. Okay? Now, what is our objective? Our objective is to look for the endpoints of the latus rectum. Where is that latus rectum? Again, you go back to the idea of the parabola, that the latus rectum of the parabola is the chord or the focal chord that passes through the focus going to the other side of the curve, connecting that point at the other side of the parabola. So that is the latus rectum. So what is the latus rectum? From the parabola, as you can see, if you notice, our hyperbola is somewhat opposite. Okay? They're opposite parabola, right? Okay? So parang a parabola that is open to the right, and another one in here is a parabola that opens to the left. They're but just opposite. Now, notice that of course we can use in here the idea of the latus rectum in the parabola to discuss the latus rectum of the hyperbola. Okay? To discuss the idea of the latus rectum of the hyperbola. Now, another one, the purpose of discussing the endpoints of the latus rectum wherein we have in here, going to this one, is for us to at least accurately graph a hyperbola. Okay? Meaning, when we determine these points, when we determine these points under our hyperbola, then at least our graph is more accurate than what we have just discussed yesterday. Okay? Do you follow? Now, again, what are the endpoints? The endpoints, meaning to say there is no measure in here that you can see. So if I were to have the endpoints, I can say that point 1, I will use this one to be my point 1, is the same as x and y. That is the point. How about the point 2? My point 2 is the opposite on the other side. That is the same as x and y. X and negative y. But notice, when we are talking of the hyperbola, the given are always the variable a, b, and c. Okay? Common, the given is always the variable a, b, and c. And so, we cannot use this one. Okay? We cannot use this one as our point. Okay? As the endpoints of our endpoints of our latus rectum under our hyperbola. What are we going to use? Definitely, when we are going to name these points, they must be named in terms of A, B, and C. Yan. They must be named, they must be a coordinate in terms of A, B, and C. Now, let's try to look into this one. Now, notice that in our point 1, the measure of x is actually what? It is actually C. C. So meaning to say, if I have to replace that one, my point 1 could be renamed as C and Y. Do I have a name for Y? I do not have. Why? Because I do not know if this will correspond to that point. No, it's not. They are not corresponding points. The B do not correspond horizontally to these points. Tama? Okay. So meaning to say, I will maintain that one as my Y. Okay? I will maintain as my Y. How about the other one? How about the other one? Definitely, it follows that the point 2 and point, that is the same as still, what is your X? What is your X? C. But your Y is a problem. Okay? Meaning to say is still Y. Okay? We have to look into the Y in terms of what? Because we have been using C in terms of A and B. Okay? So those are the endpoints of the latus rectum. Remember that when we are talking of the our latus rectum, now we always make use of the standard equation. Okay? So the standard equation is coming from the definition. Now what is the standard equation? Okay? The standard equation natin. Standard equation of the latus rectum. So we have x raised to 2 over a raised to 2. What is my operation? Minus y raised to 2 over b raised to 2. Equated to a constant 1. Okay, constant. Okay? So as what we have said, when we say hyperbola, its definition is actually the opposite of ellipse. Okay, its definition is actually the opposite of the ellipse. That it says in there, when in ellipse, the sum of the distances of focus 1 to that point and focus 2 to that point is constant. What is my term? The sum. What about hyperbola? It is the opposite. Okay? What is the definition of the hyperbola? It is actually the difference of the distances from the focus 1 to that point and focus 2 to that point is what? Constant. Okay? So meaning to say, they are but just opposite. So, using this one, assuming that our hyperbola is with a center at the point of origin, we make use of this working equation. Okay? We make use of this working equation. Now, as I said, our endpoints now is C and Y. C and negative Y. What is our focus? To look for the value of Y in terms of A and B. Using this one. Okay? So using this one. Now let's try to have it in here. Now notice that in our standard equation, our X, what is our X? That is C. So using this one now, by substitution, we replace now the value of X, which is the same as C. Okay? So we have now an equation that is the same as C raised to 2 over A raised to 2 minus Y raised to 2 over B raised to 2. Equated to what? Equated to 1. Okay? What did we do? We replace your X with the value of X, which is C. We replace that one. So ayan. Okay, by substitution. Now from that, compute. Okay? From that, compute the value of Y in terms of A and B. So how is that? Let's subtract them. Subtract. What is the LCD? What is the LCD? A raised to 2, B raised to 2. A raised to 2, B raised to 2 divided by A raised to 2, B raised to 2. B raised to 2 multiplied by this one, that is the same as cross multiplied. Okay? So it will give you now B raised to 2, C raised to 2. How about this one? That is the same as saying A raised to 2, B raised to 2 divided by B raised to 2, A raised to 2. That is the same as cross multiplied. So it will give you now negative A raised to 2, B raised to 2.
Y.
I'm sorry. Y raised to 2. Okay? Now, after that one, still equated to what? Equated to what? Okay? Again, we comply or we look for the value of Y. So, how do we do that one? Cross multiply. Okay? So, that is the same as B raised to 2, C raised to 2, minus A raised to 2, Y raised to 2. Cross multiply. That is the same as A raised to 2, B raised to 2. Okay? B raised to 2. Now, what is our focus? Y. Meaning, we isolate Y from this equation. We isolate. Okay? So, we will isolate Y. So, we will put at the other side or maintain in there so that this one will be brought at the other side. Or it's up to you. Okay? Basta you isolate Y. So how would I isolate Y? I will be doing this one. B raised to 2, C raised to 2, minus A raised to 2, Y raised to 2, plus. I will remove Y. So what will I do? Plus A raised to 2, Y raised to 2. Now, notice that A raised to 2, B raised to 2. At the other side, I will also add A raised to 2 and then Y raised to 2. So that is the same as plus A raised to 2, Y raised to 2. Okay? What happened? This is 0. So what is left now is the same as B raised to 2, C raised to 2. Is equated to what? A raised to 2, B raised to 2. Plus A raised to 2, Y raised to 2. Okay? What are we trying to have in here? We are trying to isolate Y. We're trying to isolate Y. And so, let's try to bring this one at the left side. Okay? So, that is the same as B raised to 2, C raised to 2. Bring that one, it will be negative A raised to 2. Okay? B raised to 2. Or, minus A raised to 2, B raised to 2, minus A raised to 2, B raised to 2. Okay, shortcut. Okay? So, that is the same as, what is left now? A raised to 2, Y raised to 2. Okay? Now, you notice that y is being isolated. Now again, we isolate. Still, there is a companion that is a variable, variable a. How are you going to do that one? Divide. Divide both sides by a squared. A squared. Okay? Notice that when we divide, the y squared is already isolated. So we can have now y squared is already isolated, equated to b raised to 2, c raised to 2 minus a raised to 2, b raised to 2 over what? A raised to 2. Okay? Now, notice that in the numerator, there is a common factor. What is the common factor? B raised to 2. So you try to factor it out. You factor it out. So let's try to use this one. Okay? Factor it out. Let's go in here. That is the same as what? Y. B raised to 2. Factor it out. What is left? C raised to 2 minus A raised to 2. Nakukuha ba? Okay. Minus A raised to 2. What about the other one? That is the same as A raised to 2. Okay? Now notice that in here, we can extract now the square root. Okay? So we have to square both sides. Okay? Square both sides. That is the same as the square root of y raised to 2. That is the same as the square root of y raised to 2. Okay? B raised to 2 multiplied by c raised to 2 minus a raised to 2 over a raised to 2. Okay? So we extract the root. So what is the root? That is the same as y. Okay, what is the root of b raised to 2? B. What is the root? A. Do we have a root? We do not have. So it remains to be the square root of c raised to 2 minus a raised to 2. Remember that when we are talking of the hyperbola and then the ellipse, there is our working equation regarding the c, to compute for the c. Now what is that c in the hyperbola? We have c squared is equated to what? A raised to 2 a raised to 2 plus b raised to 2. Remember, we have this one. So that if we try to think of this one, we can bring out this one to be the value of b raised to 2. Now, let's try to have. What is c raised to 2? Let's try to do it. C raised to 2 is the same as a raised to 2 plus b raised to 2. Now, the question is, what is b raised to 2? Okay? What is b raised to 2? b raised to 2 is the same as, that is c squared minus a squared. See? Now, notice that is this variable, difference of these two variable, 2 squared, the variable is the same as this one? Are they the same? So if they are the same, then we can replace it with b. By substitution now, we can have now your a is equal to b over a. Replace the square root of what? Replace the square root of b raised to 2. The square root of b raised to 2. Now, notice that it is a perfect square. What is the square root of b raised to 2? B. Multiplied by b. B squared. Okay? Multiplied by b, that is the same as b squared over a. That is the value of our y. Meaning, the endpoints now, since our endpoints are this one, ito na yung endpoints natin. Now, notice, okay, since our point 1 is C and Y, then we can replace now your Y. Then our point 1 now, our point 1 is the same as C and what? What? B squared over A. So that is our endpoints of the latus rectum. Okay? So mark it. Mark that one. So endpoints and points of the latus rectum of the latus rectum. Definitely, when we will be having the point 2, this one, point 2, what? That is the other one, point 2, let's try to write it in here, point 2, that is C, and negative B squared over A. Endpoint of the latus rectum. Okay? That's the endpoint of the latus rectum. Pause mo. Okay, so notice that we have in here a sample for us to apply what we've been discussing. Okay? Notice that we have in here x raised to 2 over 25 minus y raised to 2 over 16 is equated to 1. Now, how are you going to sketch that one? Definitely, you look for the value of A, the value of B, compute for the C. Okay? And to get for the value of A, that one is under the standard equation. So, meaning to say for the A, for our A, it will be coming from this one, which is under the standard form. Okay? So, our A squared is actually 25. Getting the square root, it will give you now, that is the same as A, is equal to 5. So that is the value of our A. Now what about the B? B is actually in here, that is 16. Okay? 16. And so, B ang hinahanap natin, we are looking for B, I should say. Okay? Now, notice that the given is B squared. Okay? What is the B squared? 16. Now, what we are looking is just the B. And so, extract the root. So, what are you going to do? Extract the root both sides. What is the square root of B? That is the same as B squared, B. B squared is the same as B. Okay? The square root is B. And what about 16? That is the same as 4. Okay? So, that is how to start the sketching. You identify first the possible that you can immediately sketch. Definitely, the Cartesian plane is the number 1. Okay. Now, meaning to say in here, you look for the value of C now. Okay? C, you cannot see that one in the standard form. But as I said, to compute for the C, we are already saying that C squared is A raised to 2 plus B raised to 2. Okay? Now, your C squared is already defined by this. What is your A squared? A squared is 25. Okay? 25. What is your B squared? 16. So, plus 16. Okay? Now, C squared now has a value of 41. Now, we are looking for what? We are looking for C. So, with that, extract both sides. Ayan. So, what is the square root of C squared? So, we have C. And how about 41? 6.40. Tama? Okay, 6.40. Meaning to say, we have already these things. After that one, that's the time you're going to sketch them now. Mag-sketch ka na. You can sketch now. Okay? Sketch. Can you pause? Okay, so let's try to So, as you can see, to graph, to make a sketching, whatever the denominator or whatever the x-axis, it will always be, what's that? It will always be under your, this one, okay? So if your a is under your x variable, this a is along the x-axis. If your a is under y, your a must be along y-axis, okay? Along y-axis. But what we are trying to have in here is the horizontal hyperbola. And so it will follow yung the x-axis, okay? So notice, our a is 5, so located in here. So that is our a. Definitely the opposite is negative 5, still that is a. The measure is 5 units. Okay? The measure is 5 units. Now what about your B? What about your B? That is 4 units along y-axis. Then 4 units along x-axis. Y-axis in the negative side. Okay? Now, where is the C? Where is the C? 6.40. So most probably, that 6.40, if that is 6, most probably it is very near to, very close to 1.5, 6.5. So that is our C. What about this one? The same. Very close to negative 6.5. So that is our negative C. Okay, negative C. Now, after having this one, that's the time you're going to what? Look for the latus rectum. Do we have a working equation for the latus rectum? Yes. Where is the working equation? Latus rectum. For the latus rectum. Okay? Where is that? P is the same as C is equal to B squared over A. What is our C? What is our C? 6.40. Do we have B? Do we have A? Yes, you compute. So what is our B squared? Our B squared is 16. So 16 over A. What is our A? 5. Okay? 5. Meaning to say, that is our one of the endpoint of the latus rectum. Where is that? Let's try to locate the point in here, or the the latus rectum dito. Let's try to locate. That is the same as positive 3.20 aligned with 6.40. Negative 3.40 at 3.20 aligned with negative 6.40. Do you follow? Then that's the time we are going now to draw our hyperbola. Okay? Draw the hyperbola. Ayan. Where is our latus rectum? Our latus rectum is somewhat in here. Okay? Latus rectum. Okay? Name the latus rectum. The endpoints of the latus rectum, that is negative 6.40 and 3.20. What about on the other side? 0.20. negative 6.40 and negative 3.20. That is the endpoint of the latus rectum.